Hello students, you all know that our chemistry syllabus have become covered. Now I will decide that I will repeat to the important chapter of chemistry. Now my first topic is cement. You all know that what is cement? Cement is a mixture of lime, alumina, silica or iron oxide. When strongly heated, produced extremely fine powder form, which forms hard mass in presence of water, are called cement. Now the easily say that cement is an extremely fine powder form of lime, alumina, silica and iron oxide, which later sets into a hard mass in presence of water. That means cement is a mixture of lime, alumina, silica and iron oxide. Now the functions of this ingredients of cement. What is the function? Now lime function. Lime determines the strength of cement. Okay. Now lime determines the strength of cement. If excess lime is used in the manufacture of cement, then we all know that then less strength cement is produced, which results cracks during setting. This actually happens. The lime gets dispersed in water extensively, so the cement is easily cracks during setting. Okay. Again, if also less amount of lime is used in the manufacture of cement, then also less strength cement is formed. Now the lime determines the strength of cement. Now alumina. By the help of alumina helps quick setting of cement. Alumina helps quick setting of cement. Silica also determines the strength of cement. Okay. Silica, what is the formula of lime? Lime means calcium oxide, CaO. Alumina means Al2O3. Okay. Silica, SiO2. Silica also determines the strength of cement. Iron oxide, by the use of iron oxide, the grayish black color of cement is formed. For coloration, iron oxide is responsible. Okay. Now gypsum. What is the formula of gypsum? The short question from this topic is write down the formula of gypsum. Now the gypsum formula is calcium sulfate, CaSO4 dot 2 molecules of water, 2H2O. Okay. Gypsum, what is the formula of gypsum? Write down the formula of gypsum. Then the answer is calcium sulfate, CaSO4 dot 2H2O. Calcium sulfate and 2 molecules of water. Okay. Now gypsum controls the setting time of cement. Gypsum controls the setting time of cement. Now the lime determines the strength of cement. Okay. Alumina helps quick setting of cement. Silica also determines the strength of cement. Okay. Iron oxide is responsible for coloration, grayish black color of cement. Gypsum is also controls the setting time of cement. Okay. Now Portland cement. What is Portland cement? Portland cement is the extremely fine powder form of calcium aluminate and calcium silicate. Portland cement is the extremely fine powder form of calcium aluminate and calcium silicate, which later sets into a hard mass in presence of water, is called Portland cement. Okay, extremely fine powder form of calcium aluminate and calcium silicate, which later sets into a hard mass in presence of water. So they are called Portland cement. Now what is the composition of Portland cement? The composition of Portland cement is this 2CaO dot SiO2. That means dicalcium silicate. It is the formula of dicalcium silicate. The composition of Portland cement is dicalcium silicate 2CaO dot SiO2. Tricalcium silicate 3CaO dot SiO2. Okay, tricalcium aluminate 3CaO dot Al2O3, and this is tetracalcium alumina ferrate. Okay, 4CaO dot Al2O3 Fe2O3, and magnesium oxide and calcium oxide. This is the composition of Portland cement. Okay. Now what is the raw materials of Portland cement? Raw materials means kacha mal. Okay. Raw materials are two types, that is calcareous materials and argillaceous materials. Calcareous materials means chun jatiyo padartho. Now calcareous materials supply lime, Li mean lime, that means CO, and is obtained from calcium carbonate CaCO3 or limestone. Okay, calcareous materials supply lime obtained from calcium carbonate. Okay, argillaceous materials means mati jatiyo padartho. তাহলে argillaceous materials supply iron oxide, okay, Fe2O3, iron oxide, okay, alumina Al2O3 and silica SiO2. These materials supply iron oxide, iron oxide, alumina, silica obtained from volcanic eruption, slate, shale, etc. Okay. Now the raw materials is calcareous materials. Calcareous materials supply lime obtained from calcium carbonate. Argillaceous materials supply iron oxide, alumina and silica obtained from volcanic eruption, slate, shale, etc. Okay. And what is the composition of Portland cement? Dicalcium silicate, tricalcium aluminate, tetracalcium aluminopyrite, magnesium oxide, calcium oxide. This is the composition and this is the raw materials. And the definition is Portland cement, calcium aluminate and calcium silicate extremely fine powder form, which later sets into a hard mass in presence of water they are called Portland cement. Okay. Now manufacture of Portland cement. Okay, Portland cement. There are two process for the manufacture of Portland cement. One is wet process and second is dry process. Now wet process, at first in this wet process, at first raw materials containing calcium compound. Okay, at first raw materials containing calcium compound is grinded in a gyratory crusher. Okay, at first the raw materials containing calcium compound is first grinded in a gyratory crusher, then passed through ball mill. For what? In order to get extremely fine powder form. Okay, in order to get extremely fine powder form, this materials is passed through the ball mill. Okay, now the materials is then passed through wash mill. For what? For washing the materials. Okay, then the materials is passed through ball mill. Okay, and now the materials is taken in a wash mill and washed well with water. As a result, several unwanted substances get removed from the mixture or removed from the materials and to get wet argillaceous compound, and to this wet argillaceous compounds other raw materials are added, and when other raw materials are added we get slurry. We get a compound which is known as slurry. Okay, now this slurry is stored in a tank. Now the first point, wet process. What is wet process? Wet process, at first raw materials containing calcium compound is first grinded in a gyratory crusher, then passed through ball mill in order to get extremely fine powder form, and then the materials is taken in a wash mill and washed well with water. As a result, several unwanted substances get removed from the materials and to get wet argillaceous compound. To these wet argillaceous compounds other raw materials, that means other argillaceous compounds are other raw materials are added to these materials and we get slurry, which is then stored in a tank. Okay, now similarly dry process at first raw materials, that is calcium compound or argillaceous compound, is separately grinded in a gyratory crusher, similarly then passed through ball mill in order to get extremely fine powder form, and then after ball mill then the materials is taken in a mixing chamber and mixed well to get raw meal. Okay, now the compound obtained from dry process is known as raw meal. Now, firstly, calcium compound and alkylous compound is separately grinded in a gyratory crusher, then passed through ball mill in order to get extremely fine powder form, and from this a mixing chamber. Okay, mixing chamber. Now the materials are taken in a mixing chamber and mixed well. Okay, mixed well, and we get raw meal, which is then stored in a tank. Okay, now let's see. From this wet process we get the product we get slurry. From the wet process we get slurry, and from the dry process we get the product raw meal. It is obtained from dry process, it is obtained from wet process. Okay. Now the next process is calcination. Calcination means bhushikaran. Okay. Calcination is done by a kiln rotatory furnace. Furnace means chulli. Okay. Kiln namok ghurnayman chulli. Now calcination process is done by a kiln rotatory furnace. This rotatory furnace is rotated by the help of an electric motor. Okay. In this furnace there are three parts. One is upper part and middle part and lower part. Okay. Now the calcination process is done by a kiln rotatory furnace, which is rotated by the help of electric motor. At first, slurry or raw meal is allowed to pass through the upper part of the furnace. Okay, through the upper part of the furnace, and heat is applied at the lower part of the furnace. Okay, now what are the temperature of these three different parts? Now, upper part of the furnace, the temperature is 800 degrees centigrade. Okay, 800 degrees centigrade. In the middle part, temperature is 1000 degrees centigrade. Okay, at the lower part, the temperature is 1500 degrees centigrade. Now there are three different temperatures. From this topic, short question is also that what is the temperature of the middle part of the furnace during the manufacture of Portland cement. Okay, middle part temperature koto? 1000 degrees centigrade, upper part 800 degrees centigrade, and lower part 1500 degrees centigrade. Now the slurry or raw meal is allowed to pass through the upper part of the furnace, and heat is applied at the lower part of the lower part of the furnace. This is rotatory furnace. As the furnace is rotates, so the materials gradually moves down to the lower part, and where it is heated at 1500 degrees centigrade. As the furnace is rotates, so the slurry or raw meal materials are gradually moves down or descends down and reaches at the lower region of the furnace, where the materials is heated up to 1500 degrees centigrade. Okay, now the calcination process is complete. Calcination process is done by the help of kiln rotatory furnace. Okay, this rotatory furnace is rotates by the help of electric motor. Now slurry or raw meal is first allowed to pass through the upper part of the furnace, and heat is applied at the lower region of the furnace. As the furnace is rotates, so the materials gradually descends down at the lower region, where the materials is heated up to 1500 degrees centigrade. Now this is the calcination process. Okay, now the Portland cement definition. What is definition of Portland cement? The important question from this topic is describe wet process or dry process for the manufacture of Portland cement. Then calcination process is complete. Now what are the reaction of the furnace. Reaction inside the furnace. Okay. Calcination process. Then next step is reaction inside the furnace. Now the reaction inside the furnace, the next portions I will discuss tomorrow. Okay, I will discuss the next portion tomorrow. Okay.